Hello, I'm Matthew Erickson. This is our assignment 4 for GAM470. This week we had a couple of different assignments dealing with the shader classes and texturing 3D objects. Our first one was to create this shader color optimized. It was pretty much the same as a normal shader class. We just wanted to have it compute all of these in one rather than having it to have to call two different things, and we would just have this one multiplication, get it done, and then it wouldn't have to be done on the graphics card. We run this one and we can see that it's going to work in a second here. There it goes. And as we move it around, you can see it's still a cube, functions like we would think it's supposed to. Then we had to do 5 objects using that class. Pretty simple. I got the 5 objects here. One triangle's way up in the air. I should put it in a different spot, but oh well. You can do different colors and things. And the main thing about this one was that you had to, in order to cut down the amount of multiplications you need to do with the matrices, in the draw step, you can just do the projection times the view once, or sorry, view times projection. Order matters, as I found out, which took me a while. Should have known, but it happens. And then, just for each one of the different objects that we want to create, you just times the world matrices times the already gotten product of these two, and then you can set the context and render like we have been doing normally. The third one was the already textured pyramid. Pull that up here quick. This one was another one that was pretty easy. You can see all the different ones. The big thing with this one was the UV values for the top of the pyramid. You needed to make sure that it was going from 0.5 and 0. That'll get you right in the middle of the texture at the top. And we had the wrapping of the cube, which again, this one was just getting your UV values right. I noticed that there was a nice convenient grid that was broken up into 8 spots, so that's why it's divided by 8, and then I just count the amount of lines over. Could have done the math, but this was just easier to look at and made it relatively simple to just wrap it around. The last thing we had to do was creating the shader texture shader class. Say that 5 times fast. This one, once again, was pretty simple. It was a lot like we had done in the first problem, where you set up all your matrices, all your functions that you're going to need. It's going to be very similar. Set up the layout, the buffers, then the pass in the cam matrices, the world matrices. The big new one was just getting this texture and having that set to context in here. And then once again, you've got the same set to context that we've kind of been using. Running this, you see once again, then I cube. So that works out pretty well. Then in the further work, we had to do the performance tests, the performance tests and the unit box with the different faces and different filters and address modules. Doing this one, set it back to what it was before I was messing with it. When we go ahead and run this in mipmap filter, assuming it wants to run here, this takes a little bit to load or build. It probably has to do with my recording software. But in mipmap, you see everything's nice and clear. It doesn't really matter too much on the filters you decide to use, because it's trying to make everything nice and clear. Sorry, not the filters, the addresses. The address modes. Then when we change to the linear instead of the point, it tries to kind of blend everything together instead of just making it solid crisscross like it was. Oh, I have the border one turned on. Cool. As you can see, it kind of blends things, and then I'm using the border address right now, which gives us that black along the sides. If we go through here and we change this to like, let's change it to wrap quick. This one will wrap around the outside, wrap around the edge, so we'll get the blending not only on each face, but also around the edges and around the corners, different things like that. There it is. You can see it gives us a very weirdly stretched thing. Now this is only right now going along the X and not the Y, or sorry, not the X and Y, but the U and the V. Is only going along, I believe, the U right now. Yes, it's only wrapping along the U, so that's why you're getting there, whereas going down, it's still got the clamp on the edge. As you can see, the other two aren't really affected by this all too much, because there's just a lot more pixels, and so you don't get the blurring as much. And then if we set this one also to clamp, you get an idea of what happens. You know, this one will also let it clamp along the X, so all this side, not the X, the U, sorry, I'm getting all my variables mixed up in my head, but you can see that along the edges it's very distinct, and then towards the middle it kind of blurs them all, but you can still see kind of that square pattern that was there, the checkerboard pattern. Then for the last project, further work, we had to do some more performance testing. You did you did the 1,000 cubes. I thought I'd take it a bit farther and do the 1,000 spheres of the unit spheres we did. I had to mess with the camera a little bit to get them all to show. But yeah, here's the 1,000 spheres that I had it draw out. Depending, I'm getting about 70 to 80 frames per second right now. I think that has to do with my recording software, because I was getting about 80 to 88 before, and when I didn't have the software, and I think I may have forgotten to stop the last project too, so that's going to cause a little bit of problems too. But it runs it pretty much without too much of a problem. So yeah, and then that's all we had to do for homework, so thank you.